the same things we were doing yesterday. So now we have a negative on the outside, and that's going to affect how we graph this, but let's still do the same thing we were doing. So we'll do the 1/5 to the negative second first, and then we'll make it negative. So 1/5 to the negative second would be what? It's going to be 25, and then the negative would make it negative. So negative 25, negative 1/5 to the negative first. Negative 5, or you can think about it as 1/5 to the negative first, that would be 5, and then make it negative. Negative 1/5 to the 0 is going to be negative 1, because this part would give us 1, but then that negative is going to make it negative 1. Negative 1/5 to the first power. Negative 1/5. And negative 1/5 to the second power. Negative 1/25. Go ahead and graph those 5 points, or 4 of them. So all the other ones we've graphed have been above the x-axis. Now this one's below because of that negative. It's flipped upside down. So when we graph it, it'll look something like this. So what's our y-intercept now? Negative 1, 0, negative 1. What's our domain? Negative infinity. Positive infinity. It has not changed even though it flipped upside down, because this is going to keep going left and keep going right. So it keeps going in both directions. Range, however, is different. What is our lowest point? Negative infinity. What is the highest point? Some of you want to say it so bad. It is 0. It's never actually going to go past 0. My line's a little crooked, so it would actually be really, really close to it. But or that would be everything below 0. So it would just be the flipped version of whatever we did before. Right. Before you try this in your calculator, if we were to approximate negative 0.5, what do you think that would be in your step? I'm going to say negative 2.5, negative 2.6, something like that. What is it actually?
Negative 2.23.
Negative 2.23, so there's 2. As we've been doing these so far, have we had any x-intercepts? No. And that's really because it never crossed the x-axis. Some of the ones we'll see now will do that, but you may never have an x-intercept. It just depends on the problem. Let's go on to the next page, number 6. I'm sorry, 7 is what it is. Negative 5 to the negative second power. So this is, you can think about it like this. So 5 to the negative second would be 1 over 25, and then that would be negative 1 over 0.5. It's basically what we just did, but in reverse. Actually, because it's not parentheses, I'm thinking, does the negative matter? I have to double check that. It's not what I'm going to do. It doesn't have parentheses, so I'm assuming it's this. Okay. Which would make it negative. What I said. Okay. So negative 5 to the negative first would be negative 1 over 5. Negative 5 to the 0. Negative 1. Negative 5 to the first. Negative 5. And negative 0.5. If this one had parentheses, it would be positive. Same thing with negative 5 to the negative second. So it's basically what we just did, but in reverse. That's not supposed to be all the way up there. So that y-intercept would be 0, negative 1. The domain would be negative infinity to infinity. The range is our lowest with our highest. Negative infinity to 0. And then go ahead and, you can guess if you want to, but go ahead and put that in your calculator. Negative 5 to the 0.5.
Negative 2.23.
Do that one more time.
Negative 2.23.
Negative 2.23. Right. Now we're going to try some where it does different things, gets a little bit bigger, or there are different numbers in front. So like number 8. So now when we do this, we're still going to do whatever the base is, 1/4 to the negative second, but then we're going to multiply that number by 3. So 1/4 to the negative second will give us what? Say it again. It would be, take it, flip it, and then square it. 16. And 3 times 16 would give us
48.
1/4 to the negative first would be 4, and then times 3, 12. 1/4 to the 0 times 3, 3. So that would be 1 times 3. 1/4 to the first times 3. So that would be if we flipped it, but not for this one. 3/4. It'll be 3/4. You don't flip it over in that one. 1/4 to the second power times 3.
3 over 16.
3 over 16. So many of these points we can't actually graph. This one, just put it above the graph to the best of your ability. Let's say it's somewhere up there. 0, 3, 1, 2. Something like that. But what's our y-intercept now? 0, 3. That a value changed our y-intercept from 1 to 3. Did our domain change? No, it's the same. Negative infinity, positive infinity. What about our range?
Yeah.
What is it? Lowest to highest? 0 to infinity. Right. Go ahead and put this in your calculator. Make sure you're using the parentheses. Put 3 times 1/4 to the 0.5. What would that give us?
1.5.
And if I had looked at where 0.5 would be, that's probably what I would have guessed also. Questions on that before we do 9? It'll be similar to 8, but instead of the fraction, we have a whole number base. 2 times 8 to the negative 2. Give it to me as a fraction.
As a fraction.
So if you figure out what this part is, 8 to the negative 2, and then multiply it by 2, you'd have to simplify it. What'd you get?
3.25.
Okay, so what would 8 to the negative 2 be as a fraction? 1 over 64. So in your calculator, you would put in 2 over 64. But the decimal should match. 2 times 8 to the negative first. 1/4.
Yeah.
So it would be 1/8 times 2. 2 times 8 to the 0. 2. 2 times 8 to the first.
16.
16. And 2 times 8 squared.
128.
128. So 64 would be the first part, and then you multiply it by 2. So again, 1, 16, just kind of graph it off, but the rest we couldn't do. What is our y-intercept here?
2.
0, 2. Make sure you're writing it as the order pair. Domain, our range. 0 to infinity. And go ahead and approximate this. 2 times 8 to the negative 0.5.
0.707.
Say that one more time.
0.707.
707, so 0.7. Alright. We're going to do 10 and then we're going to skip to some other ones. Now we have a negative a value and a whole number base. Let's see what happens there. So do 9 to the negative second power, multiply that by negative 3. Will that simplify? It might. I don't know to what. You put it in and it didn't simplify.
Yeah. Oh,
So what? It's okay. Negative 3 times 9 to the negative 1. What would that give us? Negative 1/3. Negative 3 times 9 to the 0. Really, you could, once you find one and find the next one, if you find the pattern, which is multiplying each set by positive 3, or I'm sorry, by positive 9, then this next one would be
Negative 27. Negative 242.
negative 243.
Yeah.
Okay. And then graph those. Oops, that was wrong. Okay. The rest we wouldn't really be able to graph, so you're just going to assume where the rest would fall. What's our y-intercept? 0, negative 3. Domain. Negative infinity to positive infinity. Range. Negative infinity to 0. And go ahead and approximate this.
Negative 1.
Negative 1, exactly, okay. And then it says negative 1, not negative 1. Did you not get the same things? Go on to find 15. So now you have something where you have a blank table. You could do one of two things. Either put this in, find the y-intercept, put that in the middle and start there. Or, actually, let's do that first. So go ahead and put this into your y equals. And then go into your table. You want your y-intercept in your table, and then that may or may not give you points you can actually graph, but you just want to put points in your table regardless. You could leave it as a decimal or change it to a fraction. I don't remember to do that right now. But I'm just going to put the decimal. So I'm just going to put the same numbers we've been using, negative 2 to 2, and then just put those numbers in. And then we're going to graph those to the best of our ability. So in this case, when you added something, it moved it up, which changed our y-intercept. And our y-intercept is now what? 0, 4. what's our domain? Negative infinity to positive infinity. That has not changed, but what's our range now? What's the lowest to highest? 4 to, actually not 4, but where is this getting really close to? 3 to infinity. So the 4 is going to be your y-intercept, but that's not going to be the lowest one. So always make sure you're looking at the lowest one. This number will usually tell you what that is. We're not approximating in this one. 16 and 17 are more challenging ones. Do you want to do both of these or just one of them? Okay, pick one.
6.
Okay. So go ahead and put that in your y equals. Make sure you're using parentheses. And then go into your table. Our y-intercept is still at 0, negative 7, 2, or still at 0, so we can use, again, the same x values. And then put in those y values. You can put this as the fraction or the decimal, it doesn't matter. Now, as we were doing this before, so we just found all these from the table. You could do that. You could also put each of these values. So let's say you want to start with your y-intercept, put 0 in for x. This will give me 1. 1 minus 8 is negative 7. Negative 7 times 1/2 is negative 3/2. You could do that by hand and fill out your table also, but you have choices. Either by hand or do it in the table. Graph those points. These kind of all look about the same place, but I'm trying to make them look like they're going up. It's not really working. So you start to see the curve, but not really. So if you want to add in more points, you could do that at 3, 0, 4, 4. You don't need to put those on the table, but you can if you so choose. What's our y-intercept there? Our y-intercept? Negative 3.5, 0, negative 3.5. Domain is the same, negative infinity to infinity. Our range, what's our lowest point? Negative 4 to infinity. Alright. I'm going to let you practice in a second. On the very last page, there's a challenge question. My hint to you would be try to find the change, what happens as you move to the y values, and that might help figure out what equation this would be. And you could try to put that in and see, okay, if I put this in, do I get the same points? But that is a problem to try. So for the remainder of class, you could be working on the problems we didn't do, the delta math on this, let's do next week. the delta maths that are due today, which is the dividing polynomials and the characteristics of quadratics. The dividing one is formative, the other one is not, but still practice it. Day labs, SOL practice that's due Monday, any of those. So use this time wisely. Let me know if you have any questions.